Over 200 years ago, Alessandro Voltaire invented the first battery. He discovered that by placing copper and zinc discs on top of each other and separating each with a brine-soaked cloth, he could create an electrical power source. His invention was called the voltaic pile, in honour of the inventor and because it was, well, a pile of materials. The basic principle of battery construction has not changed to this day. Batteries are made up of cells. Each cell has a positive cathode and a negative anode. The anode and cathode are kept physically apart with a separator. But for the cell to work, both are placed in contact with each other via electrolyte. In this state, the cell is almost inactive. It only has the potential to create electricity. When connected to an appliance, a chemical reaction takes place within the materials which causes electrons to flow through the circuit. The materials which make up the cathode, the anode, the separator and the electrolyte vary depending on the type of battery, or as it is known, the battery chemistry. There are numerous chemistries, and numerous types within each chemistry. In this film, we'll look at how a lithium battery is made. The process starts with a cathode plate, an anode plate, and a separator which will keep the plates apart. The exact material that makes up the cathode and anode vary depending on the type of lithium battery being produced. These elements are wafer thin, less than half the width of a human hair, which is why it is possible to create extremely small lithium batteries, so small that they can fit on a fingertip or inside a credit card. The thin plates and separator are also incredibly flexible, which means they can be wound together in almost any shape imaginable. Metallic tabs are fixed to the anode and cathode plates, which will act as connectors between the plates and the terminals. The cases can be metallic, wrapped in a plastic cover, a soft foil pouch, or a hardened plastic shape. Electrolyte, which will allow chemical reactions to take place between the anode and the cathode plates, is then pressure injected into the case. Cylinder-style batteries have a terminal added to the top and bottom. Pouch-style batteries usually have a wire lead connector fixed to the tabs and then the pouch is sealed. Batteries in hard plastic cases have terminals fixed to the metallic tabs and are then sealed shut with a hard plastic lid. Now, although the thin plates of lithium batteries allow batteries to be made in almost any shape, this isn't always what you find when looking inside a lithium battery. The battery in your cell phone usually is made up of an anode, a cathode and a separator rolled into a tablet shape. However, if you open a laptop battery, more often than not, you'll find it is not plates rolled into the shape of the case, but actually a collection of cylinder-style lithium cells. We've covered the basic process of how lithium cells are constructed, but there is actually more to a commercially sold lithium battery than this. Lithium batteries hold a large amount of energy, and if they short out, this can quickly lead to explosions or fire, in a process known as thermal runaway. In this CCTV footage, watch the laptop in the middle of the office, which has been left to charge. A short in the battery causes so much heat to build up so fast that it literally causes an explosion and creates a temperature high enough to instantly start a fire. These issues plagued lithium batteries in their early days, and so manufacturers had to find a way to stop faulty or damaged batteries overheating if they shorted out internally. Modern lithium batteries now employ multiple safety features. Vents are added to stop heat and pressure building up that can lead to explosions. A positive temperature coefficient material increases in resistance if the battery becomes hot, which effectively cuts off the positive terminal from the plates inside. A circuit interrupt device is a metal alloy which changes shape when the temperature rises above a certain point, and by doing so also disconnects the positive terminal from the inner plates. In other cases, cells or batteries can have protection circuit boards, or PCBs. These can sometimes be so small that they are hardly noticeable in the finished product, or highly complex, especially in the case of battery packs where the results of thermal runaway are more serious, because heat spreads from one faulty battery to surrounding healthy units, causing them to short out and melt down one after another. PCBs monitor the battery or batteries and can be programmed to follow complex rules for multiple scenarios. All these different safety features have been largely successful, and thermal runaway incidents are now extremely rare in a world where billions of lithium batteries are used every day. However, lithium batteries with none of these safety features still do make their way into the market, so be sure to only purchase from reputable sources. Now you know how lithium batteries are made, remember to check out our other videos about lead acid, zinc carbon, nickel and alkaline battery types. And for more information on all battery related topics, simply search Battery Guy Knowledge Base or visit us at batteryguy.com/KB.